Hi everyone, this is Richard. In this video we are going to go over Project Euler problem number 2. When we solved problem number 1, we really did not need to use functions. It was simple enough. From here on out, functions will really help us out, and this is going to be an example of that. So I'm going to break tradition a little bit. Usually I type out the functions in front of you, but this is like the 59th video right now of this, and I had to redo it over and over again because it's just a sloppy mess. So I'm going to spare you for that, okay? And I'm going to type it out ahead of time, but I'll walk you through it and explain it and see how we do it. And I'll talk about how my thought process is of doing this. But I'm going to try to make two videos. Number one, I'm going to solve this the incorrect way, then I'm going to solve it the correct way, and I'll explain it to you, okay? So first of all, let's go through the problem. By considering the terms in a Fibonacci sequence whose values do not exceed 4 million, find the sum of even-valued terms. What is a Fibonacci sequence? Fibonacci sequence, by definition, is a series where the first two numbers are by definition 0 and 1, and all following numbers, all subsequent numbers, are the sum of the previous two numbers. So the sum being adding the previous two numbers. So 0 plus 1 equals 1. 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 equals 8, and so on. Okay, and it keeps going on from there. So when I look at this, I see several things. Number one, how are we going to calculate the next number in a sequence? Well, what I originally thought is have a variable a plus b, and then we can calculate c. But then we can use c plus b and reuse a and calculate a. And then a plus c, b plus c plus b equals a. Okay, I'm getting lost, and that's why this is the 59th video. Okay, I'm getting lost, and if this sounds confusing, writing it out is even worse. Okay, that did not work. Best way when you look at it, this looks like a list, doesn't it? Now, if we have a list, we notice that lists are ordered 0 place, 1 place, 2 place. Okay, so if we know that, I can always say this value is this place, the value is this place minus 1 minus 2. Okay, so 0, 1, 2, 3, 4, 5, this is the fifth place. It's the result of the sum of 5 minus 1, the fourth place, 5 minus 2, the third place. That was a bad example. Here's a sixth place. 1, 2, 0, 1, 2, 3, 4, 5. So this is the sixth place, value 8. The value 8 is the sixth place in the list, minus 6 minus 1, which is fifth place, 6 place minus 2, which is the fourth place. Fourth place plus fifth place, the values equal 8. Fourth, fifth, sixth place. I hope that's clear, okay? So that's what I think is the easiest way to calculate the Fibonacci sequence. Now, if you remember this function from before, this is a very simple way of calculating a Fibonacci sequence. There's two problems with it. Number one, it's slow. It actually, if you put a high number inside of here, this actually is very slow to calculate because it has to keep counting all this thing over and over and over again. But the second thing is it's a little cheating, okay, right? So in Project Euler, we want to try to think about these problems and how to solve them ourselves with minimum cheating, okay? So let's not use this, and let's try to use our own system. But when I look at the answer, it says whose values do not exceed 4 million. So if this is a list, it's not telling you the 4 millionth in the Fibonacci sequence. It says which of these values, again, in a list, these would be elements. The element which value is not 4 million, and the sum of even valued terms. Okay? So what I did, since we don't know the length, what position it is, we could use a for loop, but we probably want to use a while loop. We'll do both. A while loop is as long as this sequence, the values are not over 4 million, continue. As soon as it exceeds 4 million, halt the loop. Here, Fibonacci while function. I'm going to return a list of integers. The parameter is upper limit. Upper limit is going to be the 4 million, right? It's the upper limit of these values. List, the Fibonacci list, is going to be what we're going to return. We need a counter. We need a means to count all the way up through the list. And the next number is what I was mentioning before. This value, the next value, or next number, you're going to calculate from the preceding two values. So if we go through here, counter equals 0, while the counter is less than 4 million, remember, proceed on with the loop. So counter is equal to 0 is less than 2, so add to the Fibonacci list. Fibonacci list.add using the method add. This number, which is 0, so it's no longer blank, an empty list. It has 0 in it. Else, we're going to skip there. Counter plus plus. Remember, that is the same as counter equals counter plus 1. We loop back through. So now counter has the value of 1. It's still less than 4 million. Counter is less than 2. It adds that onto the list. All right? Skip this because this is true. Counter plus plus. Counter has the value of 2. It's less than 4 million. This is false, so it goes through the else. This new variable, next number, equals Fibonacci list counter minus 1 and counter minus 2. Okay, so in other words, it is the value of 2. 2 minus 1 equals 1. 2 minus 2 equals 0. So it goes to the list and says Fibonacci list 1, which is value 1. Fibonacci list minus 2 is 0. 0. The value, the position 0, the position 1, add those two together, and it gets us next number, which is value 1. If the next number is greater than upper limit, 4 million, it is not, false, else, add it, Fibonacci, and the next number. Okay? Counter, hope I'm not boring you. Add one more. It has the value of 3. Still less than 4 million. It is greater, this is false, it goes here. So Fibonacci list counter is 3 minus 1, so position 2, 0, 1, 2, this, plus the Fibonacci list 3 minus 2 equals 1, 0, 1. So the 2 position plus the 1 position equals 2. So next number equals 0, 1, 2, 3 position, the value of 2. If next number is greater than upper limit, 4 million, no, it goes to the Fibonacci list, add the next, and it keeps adding on and on. Okay, what if we keep going up way up inside of here? So counter goes up here. If the next number, and it keeps going looping through, if the next number equals the preceding two numbers, and this value is greater than 4 million, so let's just say it hits 4.5 million, then counter equals the upper limit. So counter, let's just say, is on 60, okay? But the next number equals 4.5 million, so the 60 position value is 4.5 million. Then the counter would just jump to wherever it was 60 before, let's just pretend, and now it jumps to 4 million, okay? That is true, so this gets ignored, goes to the counter, 4,000,001, loops around, counter is less than or equal to 4,000,001, false, the loop ends. Okay, because remember it said right here, do not exceed 4 million. It could equal 4 million, but not exceed 4 million. Okay, it ends and then it returns the Fibonacci list. Okay, so it lists all the way up to 4 million. We're not done yet. Find the sum of even valued terms. So that should be pretty easy. So we're going to have to do a sum equals 0. Okay, and that's going to be our answer. So we'll probably want to do a for loop this time. Why? Because we have a list. We know how to calculate the list, the length of a list, right? List times length, list dot length, excuse me. So let's go list answer equals Fibonacci while 4 million, right? So we're going to create a variable for the function and call the function with the upper limit being 4 million. Answer.length, right? Because we're going to loop through the entire list of the Fibonacci sequence. Okay, and then now if, because we only want the even value terms, okay? So if, let's just say, answer I dot is even, okay, we're going to cheat a little bit. We're going to use a method here because that's built into the system. I don't think that's cheating too much. If this is true, okay, we don't have to say equal to true. That's redundant. So we just say is even, right? Sum plus equal to answer I. Okay, only if, okay, and remember this is, again, sum, it never hurts to review, sum plus answer I. That's the same thing, right? So it'll only add it if it is even. Otherwise, it'll just skip through. And let's go ahead and print the answer here. Here goes nothing, okay? I hope that's the correct answer. If it's not, don't worry, I'm going to delete this video and start over, okay? But I think that's the correct answer to the problem itself. So that's how we solved it. There is another way. So we used a while loop. Why don't we use a for loop? Okay, but the for loop has a limitation itself because we don't know exactly where we are in the list. However, if we look at the list, we notice that 5 is in the 5 position, right? 0, 1, 2, 3, 4, 5. If every value is the sum of the preceding two values, we know that the list goes linear. 0, 1, 2, 3, 4, 5, and it just keeps counting. But the values of adding the previous two values goes up exponentially, right? So in other words, it goes up much higher than simple addition, meaning that it's any position, 7, 8, 9, 10 position, is going to have values greater than its position. So this has the value of 5 and is the position of 5. This has the position of 4 and the value of 3. But after 8, position of 6 in the list, value of 8, every position from here on is going to have a value greater than the position itself. Okay, because this next is 13. It would be the 7 position and value 13. It'll always be greater. So if we used 4 million in the for loop, the 4 millionth position out here, we know that the value is going to be less than 4 million. We just know that just by looking at the list and how it's calculated, right? So we can use that to our advantage. So we'll create another function called Fibonacci 4, okay? It will ignore this part right here. It's an optional parameter. I'll show you that in a little bit. But for right now, upper limit, same thing. We'll create the list, create the next number. This time we're going to use a for loop, okay? Int I, upper limit, right here. Because again, that's the upper limit of the length of the Fibonacci list, not the values. So same concept. If I is less than 2, Fibonacci list, add. So it loops through, skips this part, adds 0 and 1. As soon as the I hits value of 2, it jumps to right here. Remember this? Same thing all over again. Next number equals Fibonacci list I minus 2 plus I minus 1. Okay? But we're going to add an extra statement here. If next number is greater than the upper limit, so if this value, the next value in the Fibonacci sequence, okay, is greater than what? The upper limit, 4 million. So if the value is greater than 4 million, break. All right, that's all we have to do. So we just go ahead and break. So no matter where we are in the for loop, we just break it. Else, if it's not greater than the upper limit, go ahead and add it on top of there. Okay? Then we will return the Fibonacci list. Ignore this for a second, okay? Return the Fibonacci list, and it comes up here the same thing. So We could do Fibonacci 4. Should give us the same answer. Oh, good, it worked. Okay. It just didn't copy. That actually did work. All right. But this particular one, I made, so that's the answer. All right. You can do a for loop or a while loop, a for loop with a break. If in the future, if the sequence doesn't go increase in value, it goes ups and downs, you can't always predict that. You'll have to use a while loop. Like for example, if this was 1 2 3 2 1 2 3, a while loop as long as a condition is met, but here we can always just say if the condition is met, next number greater than or equal to 4 million, break. Okay. Here I added an as an example of functions, another example what we can do. What if, for example, I want to know what is the value, like the 20th place. So what is the 20th Fibonacci number? I could put a number here. Put that inside of there, right like that, okay? So what that will do is, if actual is null, so in other words, I leave it empty, it's optional parameter, I leave it empty, then you will return the Fibonacci list. That's what we did in the first section right here, okay? If it does have actually a value, what you will return is Fibonacci list with the actual value itself. Okay, so it'll go through the list and pick that number 20 and print it out. So I'll call it, but this is going to have to be something different. Instead, I'll say, let's just delete this section. We're not going to need it again. Print answer. Object type error. Whoops, it's not a list. Whoa, sorry. There we go. And that's the 20th value in the Fibonacci list. Okay. This is interesting for a number of reasons. Number one, we get to use optional parameters themselves. Not only that, but if you notice now, I can't, this one I put list. So I was being very specific on the type. Here I really couldn't do that. Why? Because you could return a list or you could return an integer itself. So when I put list, I could put list here if it was not an optional parameter, but as soon as I started doing this, then this is going to have to be an int, right? Exactly. So that is a way which you can sort of mess yourself up, so you do have to be careful about that. All right? That's the solution. Honestly, this is the wrong solution to the problem. Now, I'll leave it up to you in terms of why you think it's the wrong solution. I'll give you my opinion on why it's the wrong solution in the next video. Stay tuned. Thank you very much for watching.